So this is problem 29.9 from homework 8, and it states, although the evidence is weak, there has been concern in recent years over possible health effects from the magnetic fields generated by electric transmission lines. So a typical high voltage transmission line is 20 meters above ground and carries a 200 amp current at a potential of 110 kilovolts. And for part A, they want us to calculate the magnetic field strength on the ground directly under such a transmission line. So I've gone ahead and drawn out our transmission line here. So we've got our pole with our wire connected to the other pole. This is the ground, and then that wire is going to be 20 meters above ground. So our R is going to be equal to 20 meters. The current they've given us, so the current going through the wire is going at 20 or 200 amps, and then they've also given us the potential, which is 110 kilovolts. And then since we're calculating the magnetic field, I just went ahead and drew the direction of the magnetic field in the picture too. It's not necessarily relevant, but I feel like it's always good to know what your magnetic field's doing. So using the right hand rule, if we have our current going this way, then our magnetic field is going to be wrapping around this way. So I'm drawing it out of the page and then going back into the page around that wire. And then we know from chapter 29, equation 29.7 gives us the magnetic field of a wire, and that's going to be equal to the permeability constant, which is just 4 pi times 10 to the negative 7 Teslas times meters over amps, and then divided by 2 pi times the current divided by R. And we have all those variables, so we just need to plug those in, and then we get our current of the magnetic field of the wire on the ground equal to 2 times 10 to the negative 6 Teslas. So that's going to be the strength of the magnetic field that we feel when we're just standing on the ground. And then for part B, it wants us to calculate the percentage, or what percentage of this is this of the Earth's magnetic field of 50 microteslas. So the Earth has a magnetic field of 50 microteslas, and they want to know what percentage is this, this 2 times 10 to the negative 6 of that. So we just need to divide, forgot to times by 100%, but you just divide the 2 times by 100%, and we find that the strength of the magnetic field on the ground is only 4% of the strength of the Earth's magnetic field. So, yeah, I think that shows that there is not possible health effects generated from these transmission lines, because the Earth's magnetic field is much, much stronger. So, yeah, that all ties into what we're learning in chapter 29, obviously with magnetic fields and currents. And the only tricky parts, tricky part on this one, notice they gave us the potential here. I don't know if that was to throw us off or what, but that was not actually relevant for this problem. So just be careful. Not everything, all the information that you're given in the problems is not always relevant. So don't get thrown off by that. And yeah, we didn't have to convert any units or anything. So this problem was pretty straightforward.